Good morning. Today we are going to learn how to do the shortcut of electron configuration, also sometimes called abbreviated electron configuration or the noble gas electron configuration. So before we get started, I wanted to show you that there's a few steps that you need to follow when you do noble gas configuration, and this makes your life a lot easier. So I would write down these steps in your notes. First, you're going to find the element that you're trying to go to on the periodic table. Okay, I put my finger on that element or my pencil, then I go up one row and I go all the way to the right. The very, very, very right column on the periodic table are called the noble gases. Okay, and so you're going to write the symbol for that, whatever that noble gas is, in brackets. Okay, so example here is like argon in brackets. Okay, so not parentheses, but brackets. Then you're going to continue from that element until you get to the element that you want using normal configuration, okay, like 1s2, 2s2, that kind of thing, okay? So the reason that we do this is because what you're telling the reader when you put the noble gas in brackets is you're telling them that you understand what the configuration is up to that element, but you're not going to write it, which is why it's abbreviated. So that prevents you from having to write 1s2, 2s2, 2p6 every single time, okay? There's another reason that we do this also, and we will get to that in a minute, okay? So let's go back to our periodic table now, and I'm going to show you a couple of examples. Okay, so here's our labeled periodic table. And so the first example that we will do is arsenic. So AS is arsenic. So what I'm going to do is I'm going to find arsenic on my periodic table. Here it is. And then I put my finger on it or my pencil, and then you go up one row and you go all the way to the right. Okay, so this whole column right here, these are called your noble gases. These are your noble gases. Okay, we'll talk about why they are called noble in the next unit. So you're going to find the noble gas before it. And so I think the easiest way to do that is to put your finger on it, go up a row and all the way to the right. So that is the noble gas before it. So I'm going to put AR in brackets, and that is where I'm going to start my configuration. So from that point on, I'm going to go to the next row, which is 4. So I'm going to write 4S2, and then 3D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 4P, 1, 2, 3. And that is my abbreviated or shortcut electron configuration for arsenic. Now, part of the reason we do this is because it's shorter and it eliminates a lot of the early stuff. Now, while they're called core electrons, core electrons are important. However, most of the time when we are looking at bonding that's happening, or we're looking at types of chemical reactions, the primary electrons that we are interested in are called valence electrons on the outermost shell. Okay, and remember how I taught you guys that as you go further from the nucleus, your energy levels get closer together. So sometimes the d electrons are, involved in that kind of situation too, which is why we include that in the shortcut configuration. Okay, so let's do another example or two. I'm going to do some also that are in the very bottom to show you how to do that. Okay, so let's erase this. Erase or arsenic. All right, now let's look at PR, praseodymium. So when you do one in one of these, you have to remember you're not going to put your finger on this one. You're going to remember this whole row is inserted right here, right? This first row is inserted right here. So that's where you're going to put your finger. Then you're going to go up a row and all the way to the right. So the one before it is actually xenon, Xe. Then I'm going to go from xenon until I get to praseodymium. So from xenon, that would be 6s2, and then 5d1, and then 4f2. Okay, so hopefully that makes sense. All right, let's do one more. We'll do one in the very bottom row. Okay, so let's now look at californium, so CF. Okay, so californium, remember this guy is in the second row. So that means it's inserted here. So that's where I would put my finger. Then I would go up and all the way to the right. So this one actually is RN. Okay, so I'm going to start at RN and I would say 7s2, and then I would go down to 6d1, and then 5F, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be my shortcut configuration for californium. Now, a couple things you need to know. Let's say that your problem gives you krypton. You are not allowed to just do krypton in brackets and be done with it. That is not allowed. So if you were given a noble gas, you have to go to the noble gas before it and start there. So you would say argon, and then you would say 4s2, 3d10, 4p6. That's how you would do that one. Okay. Now, since we were talking about configurations, this is a good time to talk about ions and how that works. So sometimes we focus so far only on elements that are neutral, but sometimes you need to find configurations for ions. So let's talk about how we do that. Okay, so if you have a negative ion, that means you are going to add electrons to the total configuration. So what I would do is I would start with your normal electron configuration. So if we're going to do nitrogen, for example, let's do nitrogen 3 minus that ion. So I'm going to start by doing the configuration for nitrogen. So I would say 1s2, 2s2, 2p3. Okay, so that's my configuration for nitrogen. Now, I know that because I have this -3 ion, that means I have 3 more electrons, and I have to add that to my total. Well, here I am at 2p3. If I were to add 3 more electrons, I would go 1, 2, 3. So that would lead me to 2p6. So I would change this 3 to a 6 because I've added 3 more electrons, and that's where they would go. Okay, so that is how I would recommend doing this. Do your normal configuration, and then if it's negative, you're going to add that many electrons. So just add that many and then figure out what your configuration would be. Okay, now let's do one that's positive. Positive ones are a little trickier, but not too bad. Okay, so let's say we're going to do calcium 2+. Whew. Okay, so calcium 2+. So I'm going to do the shortcut for this one and to kind of show you how it works. Actually, no, I'm not. Let's do 1s2. Ooh, my computer is slow. 1s2, then 2s2, 2p6, 3s2, 3p6, and then 4s2. Now, if it's a positive ion, very slow, sorry. Positive ions, you're going to subtract. Okay, it's not working for me, so you're going to subtract. Now, that means I am going to subtract 2 because my charge is +2. So you're going to go to usually the valence shell, the outermost shell, which is, in this case, 4s2. And if I remove both of these electrons, that means the whole energy level goes away. In this case, because there's no electrons there, I don't have to write that term at all. So I would just erase that entire term, and then the configuration that is left would be for my +2 ion. Okay, and that's pretty much as easy as it gets. If you just got to remember, if it's a negative ion, you're going to add that many electrons, and if it's a positive ion, you're going to subtract that many, and you always go from the outermost energy level, the highest energy level here. Okay, and that is all for today.